What if you could actually read an AI's mind? I mean, really see its thought process, not just the final answer. Well, it turns out the key isn't some crazy complex algorithm. It's a question. A question so simple, you definitely learned it back in grade school. This is one of those discoveries that's so elegant, so powerful, it completely changes the game. And it all starts with one very simple, very weird mistake.
Okay, so picture this. You have one of the most powerful AIs on the planet. A digital brain that's been trained on a massive chunk of the entire internet. You'd expect it to be a flat-out genius, right? Able to solve anything you throw at it? Well, let's give it a little test, shall we? Something really, really simple.
Here's the problem. A cafeteria has 23 apples. They use 20, then they buy 6 more. How many do they have? Now, you probably solved that before I even finished the sentence. The answer is, of course, 9. Any person gets this instantly. So, what did our super genius AI come up with?
It said 27. 27! How on earth do you get 27? It's not just a little off, it's fundamentally wrong. How can an AI that can write a sonnet or a piece of code fail at something a third grader can do? This one bizarre answer is the starting gun for our whole investigation, and it leads to an incredible discovery about how we talk to machines. So to figure out why the AI failed so spectacularly, we have to look at how we used to talk to these models. You see, the old way was pretty straightforward. You ask a question, you get an answer. And that method, well, it's the real heart of the problem here. It's called standard prompting. You just give the model a direct question, and you expect it to just spit out the right answer. Seems logical, right? But it has a massive, massive flaw. Using this method turns the AI into a total black box. A question goes in, an answer comes out. But what happens in between? What gears were turning? You have absolutely no idea what logic it followed, if any. And if you can't see the process, how can you ever really trust the result? Was it actual reasoning or just a lucky guess from a trillion-terabyte parrot? And here it is, the actual prompt and the baffling output from the research paper. The AI just gives the wrong number, 27. We don't know why. We can't see where it went wrong. We can't fix it. It's just a wrong answer coming out of a mysterious box. And for the longest time, that was a huge roadblock for making AI useful.
So how do we crack open that black box? Well, the solution is it's beautiful. It's something we all learned in school. Remember your math teacher probably looking over your shoulder saying, "Don't just give me the answer, show your work." What if we just ask the AI to do the exact same thing?
This new method is called chain of thought prompting. And it's exactly what it sounds like. Instead of just asking for the final answer, you prompt the model to think step by step, to actually generate its chain of thought. It's such a subtle shift, but oh my, the consequences are staggering. And the difference is just night and day. Look at this. On the left, you've got the black box, totally confused, answering 27. On the right, we asked the same AI to just show its work. And now it reasons they started with 23 apples. 23 minus 20 is 3. Then they bought 6 more. So 3 plus 6 is 9. The answer is 9. It's perfect. The logic is crystal clear. Just by asking it to reason out loud, it nails the problem. This simple trick forces the AI to follow a process that's a lot more like how we humans think. It has to decompose the problem, break it into smaller, manageable chunks. Then it addresses each of those chunks logically, one by one. And only then does it put it all together to form the final answer. It's not just guessing anymore. It's actually constructing a solution. And here's the part that really blows my mind. We haven't changed the AI model at all. We didn't feed it more data or rewrite its code. We didn't make it smarter. All we did was change how we asked the question. We're just guiding it to use an intelligence that it apparently already had. The ability was in there the whole time, just waiting for the right prompt to let it out. But the story has another really cool twist. Now you're probably thinking, okay, that's a neat trick. It must work on any AI, right? And the answer the researchers found was a very surprising nope. This simple technique doesn't just work on any old model. The magic only seems to happen at a truly massive scale. As the paper puts it, this only works on models with around 100 billion parameters or more. If you try this trick on smaller models, asking for a chain of thought just produces fluent-sounding nonsense. This ability to reason doesn't seem to grow gradually as models get bigger. It just switches on.
This phenomenon is called an emergent ability, and it's a wild concept. Think of it like this. A single molecule of H2O isn't wet, but you get enough of them together and the property of wetness just emerges. It's the same idea here. This complex, step-by-step reasoning ability just doesn't seem to exist in smaller models. It just materializes, seemingly out of nowhere, once you cross that massive threshold of scale.
And this chart really shows you how dramatic the effect is. Take a huge model, Palm, and give it a tough math test. With the old standard prompting, it only gets about 18% right. Pretty dismal. But take that exact same model and just ask it to show its work with chain of thought, and boom, the score skyrockets to 57%. That's more than a threefold increase, just from changing how we ask the question. It's a total game changer.
Okay, so it's a killer trick for math problems. But is that all it's good for? Well, the researchers pushed it even further. They tested it on all kinds of tasks that require real-world, common-sense reasoning, and they found that this is a much more fundamental discovery than just a way to solve arithmetic.
It turns out, chain of thought improves performance all over the place. We're talking common sense reasoning, symbolic puzzles, logic games, you name it. Let me show you a couple of really cool examples.
Check this one out. The AI reasons through a common sense problem. It correctly identifies that João Moutinho is a soccer player and that the NFC Championship is American football. It connects those two pieces of knowledge and concludes the statement doesn't make sense. That's a simple, perfect line of reasoning that a standard prompt would probably just flub.
Or look at this simple coin flip puzzle. This shows the AI is actually tracking the state of an object. It reasons that if you start with heads up and you flip it once, an odd number of times, it's going to end up on tails. This is genuine, step-by-step deduction, all unlocked by that one simple prompt.
All right, so this is way more than just some cool finding in a research paper. This simple shift in how we talk to AI has really profound implications for the future of this technology, for how we build it, and maybe more importantly, for how we can finally learn to trust it.
So why does this matter so much? Well, for the first time, it gives us a real window into the AI's mind. It makes its behavior interpretable. If it gets an answer wrong, we can now look at its reasoning and see exactly where the logic went off the rails. We can actually debug its thinking. And all of that, together, builds the foundation for trust.
We started this whole thing with a mysterious black box that gave us a nonsensical answer. But by asking it one simple thing to show its work, we've transformed it into a transparent thought process, a glass box. We can finally see how the AI thinks. And this is the critical shift from AIs that just give us answers to AIs that can actually reason with us.
And that leaves us with a final, absolutely tantalizing thought. This incredible, complex reasoning ability, it wasn't deliberately programmed into the AI. It was an emergent property of scale that we just happened to stumble upon simply by changing how we ask a question. It just makes you wonder, what else is in there? What other profound cognitive abilities are lying dormant inside these massive neural networks, just waiting for us to find the right question to ask?